In this video, we are going to make corrections to your mini assessment 2 to get some bonus points back on that quiz grade. Here we go. All right, question 1. Which of the following would you use volume to find? So first we need to remember what volume is and how is it different from surface area. So volume is the amount of units that can fill an cubic units, I should say. Cubic units that can fill an object on the inside. That is what volume is. Surface area is the area of the outside faces, the total area, I should say, of the outside faces, where we find the area of each face and put it together. So let's go through these choices and figure out what would be volume. Again, volume, amount of cubic units that can fill the inside. Surface area is the area of the outside faces. How much water it takes to fill a bottle. That would be volume because it is talking about the inside. So A would be one of them. And it says select 3. So we're going to select 3. All right, now look at option B. How many smaller boxes can fit in a larger box? So again, that would be volume because we're talking about what would fill the inside. Now let's look at C. How much cardboard is needed to make a box? That would not be volume. That would be surface area because surface area, again, is the outside faces and the cardboard that makes up the box is the outside faces. So that would actually be surface area. For D, how much wrapping paper do you need to wrap a present? That would also be surface area because wrapping paper is the outside. You wrap the outside of a box. You're not filling the box inside with wrapping paper. And option E, how much trash can fit in a trash can? That is also volume because we are talking about filling the inside. All right, let's move on. Name the polyhedron that this net would create. First off, we need to think about what is a polyhedron. A polyhedron is just a 3D figure. So let's just remember that. We have here different prisms and pyramids. We need to first remember the difference between prisms and pyramids. Let's start with prisms. Prisms have rectangle sides and 2 bases. In other words, they have a top and bottom, or front and back. Pyramids have triangle sides that come to a point. And they only have 1 base, just a bottom. So first, let's talk about, is this a prism or a pyramid? If you said prism, you are correct because we see rectangle sides and we see 2 bases, a top and a bottom here. It is not a pyramid because there are no triangle sides and it wouldn't fold up to a tip. Now we need to think, would this be a triangular prism? Do we have triangle bases or do we have rectangle bases? Are my top and bottom triangles or rectangles? They are rectangles, so this would be a rectangular prism. All right, let's move on. Now name the polyhedron that this net would create. I'm just going to copy and paste what we wrote for the last slide, because we're still talking about a prism or a pyramid. All right, first we need to decide, is this a prism or is it a pyramid? We know that it is a pyramid because we have triangle sides and there is only one bottom. So that is why we know it is a pyramid. Now we need to decide, is it a square pyramid, or actually that's the only option for a pyramid here. So we know that it is a square pyramid because it has a square bottom with triangle sides that would come to a tip. All right, let's keep going. All right, name the polyhedron this net would create. So we have here, first I'm going to paste our information again. Let's decide prism or a pyramid. Does it have rectangle sides, or does it have and two bottoms, or does it have triangle sides that come to a tip and just one bottom? This would be a prism because we have rectangle faces, and then so we know it's a prism. Now let's decide, is it a rectangular prism or a triangular prism? This is a triangular prism because we have two triangle bases. All right, let's keep going. Find the surface area of the given figure. Explain how you found it. Enter your explanation in the space provided. All right. We have here a rectangular prism and we're given its dimensions. To get the surface area, we need the area of each surface. All right, so first what I'm going to do is I'm going to list out my surfaces to get the area of. We have a top, we have a bottom, we have a front, we have a back, and we have a left, and we have a right. Those are the sides that we need. Now let's find the area of each. If I put a rectangle over my bottom piece here, those dimensions would be 10 times 4, which would be 40. And we also know that the top is the same as the bottom. With a rectangular prism, matching sides are the same. All right, now let's look at my front and my back. If I put a rectangle over the front, it is 6 centimeters high by 10 centimeters wide. So we have 10 times 6 equals 60. And the front is the same as the back. All right, now let's look at the left and the right. I'm going to bring this rectangle over. And I can't really put it at that angle, but it's fine. But we do know that for the left and the right piece, it would be 6 centimeters high, because if this side here is 6, so is this side. And then it would go back 4 centimeters. So these are each 10 times 4, which is 40. And another 10 times 4, which is 40. Now that we have all of our areas, we need to total it up to get the total surface area. 40 and 40 is 80. 60 and 60 is 120. And another, oh wait, I just made a mistake. The left and the right should each be 6 times 4, not 10 times 4. Thank you guys for hopefully catching that. So these should each be 6 times 4. That was my mistake. Even teachers make mistakes sometimes. All right. All right. And now 24 and 24 is 48. So our total surface area is 248 centimeters squared. All right, let's keep going. Find the surface area of this given figure. Explain how you found it and enter in a box provided, which I just made. Okay, so we have here a triangular prism. We have a bottom, we have a left, a right, a front triangle, and a back triangle. Notice I wrote triangle because we're going to need to remember to divide those pieces by 2. All right, let's look at the bottom. If I trace over my bottom, we have 3, and then we have 6. So our bottom is 3 times 6, which is 18. Now let's look at our left and our right sides. Our left side here is 5, if you can see that. And then, I'm actually gonna make that red. And then another line for the width we have here, which is 6. So the left and the right are each 5 times 6, which is 30. All right, now each of the triangles. The base of each triangle we can see here is 3. Let me make that red. And then the height of the triangle is 4. So these are the front and back triangles are each 3 times 4, but then divided by 2 would give us 6, because 3 times 4 is 12. Divided by 2 brings us to 6. Now that we have all of our pieces, let's add them together. 18 plus 30 plus 30 plus 6 plus 6. If I total that up, that equals 90 square inches. All right, time for our final problem. Find the surface area and explain how we got it. We have here a square pyramid. So actually, these are kind of the easiest ones to do because all of the triangles are going to be the same, which is good. All right, we have a bottom square, which is 3 times 3, and that is 9. Then we have a front, a back, a left, and a right, which is all the same. The base of each of these triangles, how do I do this? There we go, is 3 millimeters. And then it is pointing to the height of 4 millimeters. So we have 3 times 4, which is 12, divided by 2, which is 6. And again, each of these are the same, so I am just gonna copy and paste it. Work smarter, not harder. All right, now the last step to do is add them all together. 4 6s equals 24, plus 9 for the bottom is 33 millimeters squared. And that is going to bring us to the end of our corrections. I hope that we were listening and actively participating and answering the questions correctly to get those points back. We will see you next time.